In the previous chapter, I showed you how to create ASP.NET MVC controller actions that return HTML views to the browser using Razor syntax. The demo application I've been building is supposed to be a blog engine, but to this point, all I've shown you how to do is render HTML by writing code for it. Wouldn't it be nice if we could dynamically manage the blog post in our application without having to resort to code changes? In this chapter, I'll show you how to work with data by using Razor to create HTML forms, then posting that data from those forms back to a controller action, and saving that data to a database. In order to accept data from our users, we need a view for them to put that data into. So let's start by creating a new controller action and view, just like in the last few videos. To do that, we'll create a new MVC controller in our controllers folder and call it post controller. And you know what? I think our home controller is getting a little overcrowded, so let's move the post action from our home controller to this new controller. And while we're at it, let's make our view folder as well, and then move that post.cshtml file into that folder too. Now that we've got all that reorganized, it's time to create our new view. Let's simply add a new controller action to our post controller named create. Since the sole purpose of this controller action is to display a view to the user, we can just copy the index action and rename it. Next, I'll go right ahead and create the view in the appropriate folder by creating a new MVC view page, just like I used to create my other views. This time, I'll call it create to match my controller action name. Since I'm going to be using this view to create an HTML form for editing fields in the post class, the first thing I'm going to do is make it a strongly typed view by specifying the @model tag at the top of the file, and then enter the full class name of the post type. I'll also specify the layout, just as in the previous examples. Now I'll get to work creating the form post. Here I've got several options to create the HTML that I need. One option is to just handcraft the HTML form fields just like I would if I weren't using Razor. This option would actually work just fine, but Razor gives us a far better approach that will generate much of the HTML for us, and that is called HTML helpers. HTML helpers are nothing more than .NET methods that we can call right from our Razor views to render dynamic HTML for us in a much cleaner way. For example, in order to generate the form tag that we need to wrap our form in order to post it back to the server, we can just use the HTML.beginForm helper. Since this helper returns a disposable object, we actually wrap it in a using statement. When ASP.NET MVC renders the page, everything inside that using statement will be wrapped in that form tag. Once we've got our form tag, we can add some form fields. I'll start by using the HTML.textArea4 helper to render a text area element that is mapped to the body property on my post object. Notice how I use a lambda expression to select the property that I want to render the input field for. At runtime, ASP.NET MVC will automatically resolve this lambda expression to the name of that property and use that property name as the ID of this input field. And since it's C# code, if I want to rename this field later on using Visual Studio's renaming functionality, Visual Studio will be sure to rename this reference too, automatically keeping everything in sync. Now the TextArea4 helper is just one of the many HTML helpers that ASP.NET MVC offers. In fact, it's got a helper for every type of HTML form field there is. For example, text box for, hidden for, password for, radio button for, etc. There's even a label for helper to help render label tags. However, there's one HTML helper that's a little more helpful than all of the others, and that's the editor for helper. This particular helper is smart enough to look at the property that you'd like to generate an input field for and figure out the best helper to use. For example, we'll use the password helper for password fields, the text area helper for large text fields, etc. Now note that there's no HTML helper for creating buttons to submit your form. You simply use normal HTML. Before I render this page, I'll add a little bit of markup to it to make it look a little bit nicer. When we're all done, let's run our site and see how it looks. The most interesting part is to view the page source and see the HTML that ASP.NET MVC rendered for us. Notice how ASP.NET used the URL of the current action as the post action. In other words, posting back to itself. In the next video, I'll show you how to handle that post in your controller action. In the previous video, I showed you how to use Razor and ASP.NET MVC HTML helpers to render a dynamic HTML form. At the end of that video, however, we were left with a form that did nothing more than post back to itself, which really won't do us any good if we want to do anything with the post data. To accept that post data, I'll need another controller action. Since ASP.NET MVC is posting back to the same controller name as the action that rendered the view, I'm actually going to start by copying and pasting the create controller that I just created and use that to handle the post action. There's two problems with this tactic. The first problem is that I want one of the controller actions to display the HTML form to the user and the other action to handle the form post, but ASP.NET MVC doesn't know which action should handle the view and which action should handle the post. This is actually pretty easy to fix. We simply decorate each action with the corresponding attribute, HTTP GET, to mark which one is displaying the view, and HTTP POST to indicate the controller action that should handle the form post. With these attributes in place, now ASP.NET MVC knows exactly which action to pick. There's another problem though. Even with these attributes in place, the two method signatures are exactly the same, which means that this code isn't even valid C#. That's also simple enough to fix. I'll just add a parameter to differentiate the two. Recall way back in the second chapter when I showed you how to pass simple parameters into your controller actions? Well, guess what? I'm going to use that same approach to pass our post data, only this time I'm going to use a complex type. Since the form we created is to make a new blog post, I can just add a post parameter to the controller action handling my post and let ASP.NET MVC take care of mapping all of the posted form fields to this new object. Note that there are a couple of the properties in the post that we don't want the user to be able to post values for, namely the author and posted date properties. In other words, when a user submits a post, we want the post to be assigned to them, not let them say that the post was created by another user. Likewise, the posted date property is intended to save the timestamp of when the post was submitted to the system, not just any date time that the user chooses. There's a few ways to tackle this problem. Perhaps the most effective way is just to create a new object simply for the purpose of handling post data and only define the properties that you want the user to be able to submit data for. Then you can create a new instance of the post yourself and just copy the data from the request object to the real object that you want to update. Now, this is a great approach, but it does have the downside of having to maintain a whole new type, not to mention the code required to copy the properties from one instance to another. You should use this approach as often as possible, but let's try another approach. The next approach we can try is to provide ASP.NET MVC with a whitelist of all the properties that the user is allowed to specify values for by applying the bind attribute to the parameter, like this. This is a perfectly legitimate approach too. However, I try to avoid it because it becomes too difficult to maintain when you add more properties to your objects or when you change the names of existing properties. One other way is to simply overwrite the fields that the user submitted with the values that I want them to be. In other words, explicitly setting the posted date to datetime.now and the author property to the current username every single time. Now, this isn't the most elegant approach, and it's certainly not the best way for every situation, but it's quite simple and it happens to work well for me in this particular scenario. Now that I've got all the data populated, it's time to run it and see it in action. First, I'll set a breakpoint and then I'll go ahead and hit F5 to run the application in debug mode. Now I can navigate to the page, populate the fields, and post the form. And then when my breakpoint is hit, I can inspect the values with the debugger to see that ASP.NET MVC has, in fact, populated the object for me. Now there's one problem with this. I want to be able to restrict what users can enter into these fields. For example, maybe I want to make sure that blog post titles are no more than 100 characters long, or that blog posts are never completely empty and always contain at least some text in their body. Let's move on to the next video where I'll show you how to validate these inputs. In the previous video, I showed you how to handle post data in a controller action using complex types as controller action parameters. In this video, I'll show you how to validate the data that gets posted so we can make sure that only clean, legitimate data gets into our system. ASP.NET MVC has a really interesting way of specifying validation rules, and that is by attaching them right to the properties that they are validating. Since our form is posting data via the post class, let's jump to that class and start decorating it with validation rules. To begin with, let's mark the title and body properties as required, meaning that they have to have at least some text in them in order to be valid. To do this, simply add the required attribute above each of them. This attribute lives in the system.componentModel.dataAnnotations namespace, so we'll have to import that namespace in order for this to work. Next, let's specify some minimum and maximum lengths for these fields. Let's say that I want the title property to be at least 5 characters long, but no longer than 100 characters. To enforce this, I'll apply the string length attribute, and I'll provide it with the minimum and maximum lengths, 5 and 100 respectively. I can also provide an optional error message property on this attribute, which ASP.NET MVC will display to the user when they fail to meet the validation criteria. We can apply a similar attribute to the body property, only for this property, I just care about the minimum length, so I'll use the min length attribute and allow people to make their blog posts as long as they want. Now, I'm not going to demonstrate all of them, but if you take a look at the autocomplete options on the system.componentModel.dataAnnotations namespace, you can see that .NET provides you with a whole bunch of these validation attributes right out of the box. Everything from password fields to regular expression and email address checks, and even credit card number format validations. Now that we've updated the model, let's update the view to let the user know when they've violated our new rules. As you may have guessed, we do this by applying yet another couple of HTML helpers. First, we'll place a validation message for helper on each field. Then we'll also place a summary of all of the validation errors in the form by calling the HTML.ValidationSummary helper at the top. Now when we run the site and try to submit invalid text, ASP.NET MVC automatically blocks it from getting into the system and instead returns the page to the user with the appropriate error messages. Now that you've seen that in action, let's go back to the model again and see what other cool stuff we can do with these attributes. In addition to the validation attributes, the data annotations namespace has 2 other interesting attributes that help describe your model properties, the display attribute and the data type attribute. In fact, it's these 2 attributes that ASP.NET MVC looks at to determine what text should be displayed in the HTML generated by the HTML helpers that we used in the previous few videos. To demonstrate, I can apply the display attribute to the title property and set the name property to be blog post title. Then I can go back to the browser and refresh the page to see that the label for the title field now says blog post title instead of simply the name title. Next up, the data type attribute. Among other things, this attribute gives ASP.NET MVC more information that it can use to choose the correct editor template. For example, if I set the data type of the title property to datatype.password and refresh the page, I can see that ASP.NET MVC has generated a password input field rather than the standard text input field. Now clearly, this field is not a password value, so we can change the data type to something more fitting, such as datatype.text. Then if I go back and refresh the page, we can see that ASP.NET MVC now renders a normal text field. Likewise, we can apply the data type of datatype.multiline text to the body property to indicate that this property accepts large amounts of text. With this in place, we can change the view to use the editor for helper rather than the text area for helper. If we switch back and re-render the view, we can see that the proper text area is still being rendered out. Now, checking for validation errors in controllers is pretty easy too. If we need to check to see if the user has entered invalid data in a controller, we can do that by checking the model state property available in every action. Now, this property contains all kinds of useful information about the state of the model, but perhaps the most useful is the model state.isValid property, which gives you a simple yes or no answer as to whether or not the user has satisfied all of the model validation rules. You can then use this knowledge to determine how best to process the request. For example, if the user has submitted any invalid data, then just stop everything and send them back to the view to fix their mistakes. If the data is valid, however, you can keep processing the request. Actually, speaking of which, up to this point, I've shown you how to create an HTML form, post data back to your controller action by having ASP.NET MVC populate a complex type parameter, and even automatically validating that data in the process. However, the only thing we're actually doing with that data at this point is returning it back to the user. Check out the next video where I'll show you how to use Entity Framework to persist that data to the database and then retrieve it again to finally dynamically display the blog post on our site. In the previous few videos, I showed you how to use the Razor syntax and ASP.NET MVC's HTML helper methods to render strongly typed HTML forms. While HTML helpers are a very powerful tool, they tend to fall a little short when you want to customize the HTML that they generate for you. In this video, I'll show you how to gain more control over your HTML while still taking advantage of ASP.NET MVC's HTML generation capabilities with a feature called Tag Helpers. I'll start by demonstrating what I meant earlier when I said it's difficult to customize the HTML generated by HTML helpers. Now, here's the create post form that we've been building over the past few videos. I've been placing some CSS classes here and there to get some nice styling, but I'm still using the editor for HTML helper to generate the input fields using a template that ASP.NET MVC picks for me. So I have no control over what gets output to the browser. What if I want even more control over the HTML output? What if I want to wrap the HTML element with another element, for example, or render another element alongside of this one? Enter Tag Helpers. Using the Tag Helper approach, you write all of your HTML exactly the way you want it, and then apply special attributes that Razor picks up at runtime and then dynamically modifies your HTML as it needs to. To demonstrate what tag helpers are and how to use them, I'll rewrite this whole view using the tag helper approach. Before I get started though, I'll have to first include a reference to the microsoft.aspnet.mvc.taghelpers package in my project.json file. Then, after I have the tag helper library referenced, I can add the add tag helper Razor directive to any view that I want to use tag helpers in, and specify the tag helper type and assembly to be included in this view. If an assembly includes multiple tag helpers and you wish to include all of them, you can simply specify an asterisk in place of the type name. Once we've told Razor to look out for tag helper attributes, we can start refactoring our form by first tackling the HTML begin form statement. Instead of letting MVC render the form tag for us, we'll erase this line and create the tag ourselves. What we lose by doing this is the fact that the HTML.beginForm method was dynamically rendering the URL that the form needed to post to by determining the controller action and then asking the routing framework for the URL for that action. Now it's up to us to do that, but we can use tag helpers to help us out by applying the ASP-action attribute to the form tag and assigning it the value of the create action that we want to post the form back to. Then I'll run the page and inspect the source to see what happened. When I inspect the form tag, I don't see the ASP-action attribute I specified. Instead, I see a regular action attribute and it's populated with the URL of the create action. Why'd that happen? Well, the ASP-action attribute is one of the many tag helper attributes that Razor is going to look for when it renders the view. When it finds this or any other tag helper attribute, it's going to locate the tag helper class that is associated with that attribute and hand over the HTML element to that tag helper class for modification. The tag helper will then inject any generated HTML that it needs to and pass the modified HTML back to Razor. In other words, you can think of tag helpers as a way to pass a template to an HTML helper. I want to be very clear, however, though there are any number of JavaScript libraries that allow you to do this kind of stuff right in the browser, the manipulation you are seeing here is taking place on the server in the Razor View engine, not on the client side. Now that I've shown the form tag helper, let's convert the rest of the view and see a couple more tag helpers in action. First, we can replace the HTML.label4 and HTML.editor4 helpers with the ASP-4 tag helper, like so. Now that I have regular HTML that I can mark up, I can easily add some custom CSS classes. Then we can replace the HTML.validation message for helper with the ASP-validation-4 tag helper. And finally, I'll replace the HTML.validation summary with ASP-validation-summary. Notice that this tag helper actually requires a property, a validation summary enum value, which describes which validation errors to include in the summary. I've selected all of them. Now I can run the page and see my updated page in action. With any luck, you'll find that using these tag helpers tends to be a great compromise between full control over our HTML markup and the ability to have ASP.NET MVC generate some of that HTML for us. There's no reason that you can't keep using HTML helpers, but just keep in mind that you have this great tool in your toolbox. Up to this point, I've shown you two different ways to create an HTML form and how to post data back to your controller action by having ASP.NET MVC populate a complex type parameter, even automatically validating the data in the process. However, the only thing we're actually doing with that data at this point is returning it back to the user. Check out the next video where I'll show you how to use Entity Framework to persist that data to a database and then retrieve it again to finally dynamically display the blog post on our site. In the previous video, I showed you how to post data from an HTML form to a controller action. In this video, I'll show you how to define a special class with the Entity Framework library that we'll use to save that data to a database. Entity Framework is an object relational mapper, which is really just a fancy way of saying that it's a tool that allows you to save and retrieve data to and from a relational database such as Microsoft SQL Server using objects rather than hand-coded SQL queries. Before we start using Entity Framework, however, we'll have to add a reference to the package. To do this, I'll just open up the project.json file and search for the dependency entityframework.sql server, which contains all of the Entity Framework libraries that we need in order to interact with the Microsoft SQL Server databases, a version of which is on our machine right now because it actually gets installed with Visual Studio. Once we've got that package reference in place, getting started with Entity Framework is as simple as adding a class that represents the database we'll be working with. And in the Entity Framework world, this class is called a data context. I'll add the data context class for our sample project to the models folder, and I'll name it blog data context. Then I'll have this class inherit the Entity Framework base class DB context, which is all we have to do in order to tell Entity Framework that this is a data context. However, in order for the data context to actually be useful to us, we also need to define properties on the class that represent the tables in the database. And the way we do this is by exposing properties of the type DBSet of type T. For example, in order to persist and retrieve blog post objects to our database, we can define a new posts property with the following signature. DBSet of type T is an Entity Framework type that exposes a simple but elegant API that represents a table in the database as a strongly typed collection of objects that we can use the LINQ query syntax to query and filter. At runtime, Entity Framework will take our LINQ queries and convert them into SQL statements that execute against the database to return data. Entity Framework then takes that data and maps it back to instances of those strongly typed objects using a combination of standard conventions and developer-defined mapping logic. The name of DBSet properties are also crucial, as they represent the name of the corresponding table in the database. In other words, when Entity Framework is constructing SQL queries from LINQ queries that we make against this object, it will query the database table named posts. And all of the properties that we've defined in the post class will map to columns in that database table. In order to be a valid database entity, however, this post object must specify a property that will act as the primary key in the database. Entity Framework uses the convention of calling this key property ID. So I'll add a property with that name to the post class and use the long type to indicate that it should be an incremental numeric ID. We use the convention of naming the property ID because that's the name of the property that Entity Framework looks for by default. Just adding this property gives the entity a primary key, but that's it. By default, Entity Framework does not assume that you want this key to auto-increment. So we have to tell Entity Framework that it should increment this ID field by overriding the onModelCreating method in the blog data context class and specifying the following code. This chunk of code not only tells Entity Framework that it will be connecting to a Microsoft SQL Server, it also tells Entity Framework to use SQL Server's identity approach by default whenever it needs to generate an ID for a new entity. All this talk of databases, tables, and columns might be slightly confusing at this point. After all, I haven't even created a database, let alone define the schema of that database. But that's the beautiful part of Entity Framework. Not only does it take care of mapping objects and link statements to SQL queries, it's also smart enough to actually generate all of the SQL required to build the database in the first place. In fact, we can tell Entity Framework to ensure that the database is created every single time an instance of the data context is created by putting the following line in our own constructor. With this line in place, Entity Framework will check to make sure the database exists prior to making any calls to it. If it does exist, Entity Framework will do nothing. However, if the database does not exist, Entity Framework will automatically generate the SQL schema required to define the database, and then go ahead and execute that generated SQL to create a brand new database for you. With this code in place, there's one last question that we have to answer for Entity Framework, and that is, which database should I connect to, and how? And to answer that question, we have to provide the data context with a SQL connection string. We do this by overriding one more method, onConfiguring, and then adding the following line. Where I should get the value of this connection string from is a great question. ASP.NET 5 actually provides a configuration API that I'll show you how to use later on in this course for exactly this purpose. But for now, I'll just hard code the info right into the class, and we'll come back and clean it up later. This connection string tells Entity Framework to connect to the database called ASP.NET Blog on the server localDB/MSSQL localDB. Now that we've created our new data context class, let's move on to the next video, where I'll show you how to use it in your controller actions to persist and retrieve blog post data. In the previous video, I showed you how to get started using Entity Framework by creating a data context class to represent the database. In this video, I'll show you how to put that new class to good use, storing the blog post for our demo application. Since we've already done all the dirty work of creating and configuring the data context class, all that's left is to simply create a new instance of the class and begin using it where we need it. Let's open up our post controller again and go to the spot where we want to save our post and add the following lines. First, we create a new instance of the blog data context. Then we add the new post to the post collection on that data context. And finally, we call the save changes method to save those changes to the database. Notice how saving the post to the database is a two-step process. Entity Framework works on the unit of work pattern, which is really just a fancy way of saying that first you tell the data context everything that you want to do, for example, adding a new post to the database, and second, you tell the data context to actually go ahead and execute what you've asked for, which we do by calling the save changes method. It's also interesting to note that there's an asynchronous version of the save changes method called save changes async. And in fact, ASP.NET MVC has great built-in support for asynchronous controller actions. All you have to do is change the controller action method signature from iActionResult to task of iActionResult. For an even better experience, you can also throw the C#5 async keyword on there, which provides a much cleaner syntax for dealing with asynchronous calls through the accompanying await keyword that you can use within your method. Add this all together, and the final asynchronous create blog post controller action method looks like this. At this point, we can attach a breakpoint to the end of the method, run the application, and try to create a new post with this UI. When I do this, I can see that my new code is running great because the post object receives an auto-incrementing ID value after it's saved, which means that it looks like it's working. Now please note, if the part I just demonstrated has failed on your system, saying that the connection to the database has timed out, and this is the first time you're working with LocalDB on this system, it probably means that the LocalDB service is not yet running. To fix this, open up the developer command prompt and enter the following command to ensure the LocalDB service is in fact running, and then try it again. At this point, we can assume that the save has worked merely because we had to make a round trip and add the row to the database in order to get that incremented ID value back. Just to prove that it actually does work though, Let's use Visual Studio's Server Explorer to add a new connection to our database using the server name from our connection string so that we can inspect the database contents. With the new connection in place, we can open up the Tables node and then right-click on our post table to read its data. And there it is, the blog post we just added. Now that I've shown you how to add blog posts to the database, keep the idea of this new post in mind and head right on to the next video where I'll show you how to read that post right back out of the database and use that data to replace the hard-coded data we currently see when we render our post view to our users. In the previous video, I showed you how to write data to a database using Entity Framework, and in this video, I'm going to show you how to read that data back out again and display it to your users. The last thing we did was to create a post and open up the database to validate that that post was in fact saved. Be sure to keep the ID of this post in mind because we'll use it in just a minute in order to test out the code we're about to add to read that data right back out of the database. We'll do this by refactoring that post method that we originally created way back in the previous chapter, replacing its current hard-coded values with values that we've read from the database. And just like I had to do when I wanted to write to the database, the first step in reading from the database is to create an instance of the data context to work with. And just like we use the post property as a collection that represents the database table to add a post to the database, you can use link queries directly against that same post collection to query the data in that table. In this instance, we want to get the single instance that has an ID value that matches the value of the ID parameter that was passed into this controller action. In other words, if the ID parameter of the controller action is 1, we'd like to retrieve the row in the post table with the ID property with the value of 1. To do this, simply replace the existing hard-coded values with a call to single or default on the db.post property. Once we've done that, we can navigate to our post view by going to post/post, the ID of the post that we just added to our database. In other words, 1. And that's it. I've now finished showing you how to write to and read from a database using Entity Framework and ASP.NET MVC 6. Before we move on to the rest of the course, however, I want to take care of one more thing. You see the way we've got the create action implemented now, how it just returns a view in response to a form post? Well, that's bad because if the user clicks the refresh button or navigates away and hits the back button, that same data will get posted again, creating duplicates in the database. The way to avoid this is simple. Instead of rendering the post in a view yourself, just redirect the request to the controller action who's already got that responsibility. To do that, just change the view line at the end of the create action to redirect to action. The first parameter of this method is the name of the action that you want to redirect to. In our sample application, this action is post. The second parameter of this method is an anonymous object that defines the parameters to that action. So the names of the properties in this object must match the names of the target action parameters exactly. With that in place, run the site again and jump to the browser and try posting another post. This time, we find ourselves looking at the new post instead of that create post form like before. Now, each of the controller actions has one and only one responsibility. The create action creates new posts, and the post action displays existing posts. That's it for this chapter, in which I showed you how to add data access to your application using Entity Framework. But this is only just the first best practice that I'd like to introduce you to. Over the next few chapters, I'll show you not only how to optimize your application for mobile devices, but I'll also introduce you to a handful of other tips and tricks that will turn your application from simply a functioning application to a truly maintainable and production-ready one.